Man, these gas laws don't make any sense to me. Boyles, Charles, Guy, Lusaks, man, I don't understand what that even means. And a syringe, man, you added a syringe into this? I barely even know how that works. And with gas laws, Patty Cake, man, you gotta help me out here. Patty Cake, come on, man.
Patty Cake on the beat. The syringe is an everyday tool. Doctors use them. I think it's pretty cool, but how do they even work? Did you think about that? Well, today I'm gonna tell you. Let me take off my hat. First, I need to explain some gas laws. Boyles, Charles, and Guy Lusaks. You will be in awe. Each one of these is a different law about some gases, and some of them even have to do with their masses. Well, actually, not these laws. I bet you'll never guess. It's temperature, pressure, and volume that you got to address. First, we got Charles. This guy stood up and claimed as the temperature moves up, the volume does the same. Also, if the temperature goes down, it's the same way. It's called direct relationship. It's what a graph would say. The equation is volume over temperature, 1 and 2. Cross and multiply them together in order to see the problem through. In Charles' law, the pressure needs to stay the same, or else the problem displayed will eventually turn lame. The next law is Guy Lusak. This guy goes at the find as pressure goes up, the temperature isn't far behind. Much like good old Charles, it's a direct relationship. They both go up at the same time or down like a sinking ship. The equation is pressure over temperature, 1 and 2. Just cross and multiply and then you'll know it's true. In Guy Lusak's law, the volume must be constant, or else the problem will end up giving the wrong quotient. But now we got a third law named after this to boil. But prepare yourself, because this one's different. I hope it didn't spoil. Unlike the other two, this relationship is not direct. It's inverse, making the other two seem far-fetched and wrecked. What my guy Boyle here is trying to say is that volume and pressure go the opposite way. This equation has no cross multiplication. Multiply pressure and volume, now you have the education. Here the temperature has to stay the same number, then it won't work like the problems in a slumber. Those are all the laws, Boyles, Charles, and Guy Lusaks. What's with the syringe? Given all this context, a syringe can work because of Boyle's law. I know your mouth's wide open, but you've gotta shut your jaw. Since the liquid in the syringe increases more space, this makes you less pressure because there's no room to displace. But if you press it down, that space decreases, and if there wasn't a hole, the syringe would be in pieces. Then we can't forget, because the pressure just increases. The liquid gets out, and then can carry you diseases. With so much pressure, it makes the liquid leave. But this is a result of less volume, I hope you can believe. Now you understand how a syringe works. I hope you walk away with some new perks. Now you know the gas laws as well, but maybe you'll forget them. I just cannot tell.
Patty Cake, my man, you helped me out again with these gas laws. I couldn't thank you enough. You already helped me out with those polyatomic ions and some voter's paradise type deal. I don't even know what that means, but I don't care. All I know is that it hits. And man, let me tell you, this one, man, you helped me out big time. I didn't even know none of those gas laws. I didn't know my Boyles, my Charles, and my Guy Lusaks. I didn't know how a syringe worked, but you got me, man. Thank you, Patty Cake.